Dear students, so in this class now let us discuss about the Dirichlet problem for the upper half plane. So what is the Dirichlet problem for the upper half plane? It is described as terms of the equation uxx plus uyy equals 0, where x lies in between minus infinity and plus infinity. Moreover, y greater than 0. So this uxx plus uyy equals 0, x lies in between 0 and infinity with a y greater than 0 with the initial conditions ux0 equals f of x with a minus infinity less than x less than infinity with the conditions that u is bounded u is bounded as y goes to infinity. U and ux vanishes. U and ux goes to 0 as mod x goes to infinity. So this problem is known as, this is a well-known problem, and this well-known problem is known as Dirichlet problem for upper half plane. How to solve this one? uxx plus uyy equals 0 with the conditions ux0 equals f of x when x lies in between minus infinity and plus infinity. Moreover, u is bounded as y goes to infinity. U and ux vanishes as mod x goes to infinity. So this problem is known as Dirichlet problem for upper half plane. So its solution is, let u alpha y be the Fourier transform of uxy. What is the Fourier transform? Fourier transform, you are so familiar with it. Alpha y be the Fourier transform of uxy. So what is actually the Fourier transform? Fourier transform, f of f equals, let us consider the given function, then f of f equals, let f of alpha equals 1 by root 2 pi integral minus infinity to infinity f of x e power I alpha x dx. So this is the Fourier transform. So let u alpha y be the Fourier transform of uxy in the variable x. Then by definition, what is u alpha y? U alpha y equals 1 by root 2 pi into integral minus infinity to infinity according to that argument. uxy e power I alpha x dx. So u alpha y equals 1 by root 2 pi integral minus infinity to infinity. Instead of f of x, here it is uxy e power I alpha x dx. Then applying Fourier transform, what is it is given uxx plus uyy equals 0. Then by the linearity of Fourier, it is f of uxx plus uyy equals 0. That means f of uxx plus f of uyy, f of uxx plus f of uyy equals 0. But we know that if f and f dash are integrable, then f of x, if f and f dash are integrable, then f of x equals, it is minus I alpha f of x. F of x equals f of f dash x equals minus I alpha into f of x. So if f and its n minus 1 the derivatives goes to 0 as x goes to infinity, then f of fn of x equals minus I alpha all power n f of x. If f and its n minus 1 the derivatives goes to 0 as mod x goes to infinity, then the Fourier transform says that f of fn x equals minus I alpha all power n f of x. So according to that argument, what is f of uxx? So f of uxx means it is minus I alpha square, minus I alpha whole square into f of u. Agreed? According to this argument, xx second derivative with respect to the variable x, then f of uxx is nothing but minus I alpha whole square into f of u plus, what is f of uyy? It is nothing but 1 by root 2 pi integral minus infinity to infinity uyy e power I alpha x dx. Okay. F of uxx is nothing but minus I alpha whole square f of u according to this result plus f of uyy, that is nothing but 1 by root 2 pi integral minus infinity to infinity uyy e power I alpha x dx equals 0. Agree? That means minus I alpha square means minus I alpha square means minus alpha square f of u, that is u, minus alpha square u plus f of u, that is u, plus 1 by root 2 pi into integral minus infinity to infinity, it is del square by del y square of u into e power I alpha x dx equals 0. That means minus alpha square u plus del square by del y square of 1 by root 2 pi into integral minus infinity to infinity uxy e power I alpha x dx equals 0. So what about the term inside this double bracket, square bracket? That is nothing but a u itself. So that means minus alpha square u plus del square u by del y square equals 0. Okay. So that means from here we get it is uyy minus alpha square u equals 0 or del square u by del y square minus alpha square u equals 0. So the given equation reduces to this after applying Fourier transform. But the Fourier transform of the given equation is nothing but uyy minus alpha square u equals 0, which is an ordinary differential equation in y. Ordinary differential equation in y. So whose auxiliary equation is, what is this auxiliary equation? It is m square minus alpha square equals 0. M square minus alpha square equals 0. That means what is m? M equals plus or minus alpha means it has two roots. Then that gives, so which gives m equals plus or minus alpha. Therefore the general solution is it is u equals, or u of alpha is a of alpha into e power alpha y plus b alpha into e power minus alpha y. So this is the general solution. M equals plus or minus alpha. Then the general solution for this equation uyy minus alpha square u equals 0, whose auxiliary equation is m square minus alpha square equals 0. Then m equals plus or minus alpha means its general solution is u equals a of alpha into e power alpha y plus b of alpha into e power minus alpha y, which is nothing but u of xy. So it is u of uxy equals this one. Okay, uxy equals a of alpha e power alpha y plus b of alpha e power minus alpha y. But what is u? It is given. Come to the initial condition. U is bounded as y goes to infinity. What is y? Y greater than 0. That is on the upper plane. Y is greater than 0 means that is on the upper plane. Then u is bounded as y goes to infinity. Therefore, when alpha equals 0, when alpha greater than 0, it is a of alpha equals 0. Why? Because of since u is bounded. When y goes to infinity. So when alpha is greater than 0, this a alpha should be 0. Otherwise, there is u is unbounded. Then if alpha is negative, surely b of alpha equals 0. That is because of u is bounded as y goes to infinity. Otherwise, if alpha greater than 0, a alpha is non-zero, then u is unbounded. The same argument should be held here. Therefore, because of the boundedness of u as y goes to infinity, we have a alpha equals 0 when alpha is positive and b alpha is 0 when alpha is negative. Therefore, what is u x y here? Therefore, u x y equals, it is u alpha 0. It is u alpha 0 into e power minus modulus of mod alpha into y. Therefore, this reduces to, under this condition, when alpha is positive, a alpha is 0. When alpha is negative, b alpha is 0. Therefore, u x y equals u alpha 0 into, instead of a alpha and b alpha, then e power minus mod alpha y. Okay, but what is u alpha 0? Actually, what is u alpha 0? U alpha 0 means, what is u alpha y? U alpha y is 1 by root 2 pi integral minus infinity to infinity u x y e power I alpha x dx. So u alpha 0 is 1 by root 2 pi integral minus infinity to infinity u x 0 e power I alpha x dx. Agreed. So what is u x 0? U x 0 is f of x. So it is nothing but the Fourier transform of, that is the Fourier transform of u x 0. Okay. Listen, u alpha 0, according to this argument, we have u alpha y be the Fourier transform of u x y. So u alpha 0 is 1 by root 2 pi integral minus infinity to infinity u x 0 e power I alpha x dx. But u x 0 equals f of x under this condition, minus infinity to infinity. So it is u x 0 is, u alpha 0 is 1 by root 2 pi minus infinity to integral along minus infinity to infinity small f of x e power I alpha x dx. That is small f of x e power I alpha x dx is nothing but f of alpha. So it is f of alpha. Okay. So u alpha 0 equals f of alpha. Therefore, what is u x y? This implies u x y equals f of capital F of alpha into e power minus mod alpha y. But what is the inverse transform? Therefore, we have f inverse of, now consider f inverse of e power inverse transform, f inverse of e power minus mod alpha y equals 1 by root 2 pi into integral minus infinity to infinity e power minus mod alpha y into e power I alpha x dx by the, so that is from where? That is by the inverse Fourier transform. Okay, so f inverse of e power minus mod alpha y is 1 by root pi integral along minus infinity to infinity e power minus mod alpha y e power I alpha x dx. That is given as 1 by root 2 pi into integral, one is from minus infinity to 0. When alpha is negative, minus infinity to 0, it is e power alpha into y minus ix dx plus integral 0 to infinity. When alpha is positive, 0 to infinity, it is e power minus alpha into y plus ix dx. Okay, listen, when alpha is negative, e power minus mod alpha y, what is e power minus mod alpha y? Equals e power minus of mod alpha, it is plus or minus alpha y. Okay, so when alpha is negative, minus alpha is again positive. So it is when alpha is negative, it is e power alpha y minus ix, minus of minus, plus 0 to infinity e power minus alpha into y plus ix dx. Okay. So that equals 1 by root 2 pi into, which is nothing but 1 by root 2 pi into integral, then this integration, it is with respect to x, it is e power alpha into y minus ix divided by y minus I alpha, from where to where, minus infinity to 0, plus here e power minus alpha into y plus ix divided by y plus ix divided by minus of y plus I alpha. Then from where to where, it is from 0 to infinity. Then you can simplify it. It has nothing but square root of 2 by pi into y by y square minus, y square plus x square. Okay. So f inverse of e power minus mod alpha y is given as root 2 by square root of 2 by pi into y by y square plus x square. But by convolution theorem, the convolution theorem states that let f of x and g of x possess its own Fourier transforms, f of alpha and g of alpha, then L inverse of capital F of alpha into capital G of alpha is nothing but f star g of alpha. This is the convolution theorem, f star g of x. Okay, what is f star g of x? F star g of x is 1 by root 2 pi integral minus infinity to infinity f of theta into g of theta minus x dx. This is a well-known result. Then applying this result here, then you have uxy. What is uxy? Uxy is f of x star, it is square root of 2 by pi into y by y square plus x square. Then it is 1 by root 2 pi into integral minus infinity to infinity f of theta g of theta minus x dx. So it is f of theta into square root of 2 by pi y by, then it is, then that is u of xy. Therefore u of xy equals 1 by root 2 pi integral minus infinity to infinity f of theta into, instead of g, it is square root of 2 by pi into y by y square plus, instead of x, here it is theta minus x whole square dz. So this is our required result. Okay, so this is the solution of Dirichlet problem for the upper half plane. So this Dirichlet problem for the upper half plane is an important problem. It's a well-known problem whose solution is, under this condition u of xy is it is 2 and 2 cancelling each other, and it remains y by pi into root pi and root pi pi, y by pi into integral minus infinity to infinity f theta by 1 by y square plus theta minus x whole square dz. Okay, so that is the solution of this Dirichlet problem. That's a well-known problem. Agree. Now consider another important research, which is the heat conduction, which deals about heat conduction problems. Heat conduction problems. What is heat conduction problem? The heat conduction problem, there are 3 cases. First one, it's on infinite rod case. We already discussed some matters about the infinite wave. Okay, yes, here it is heat conduction problem on infinite rod case. Infinite rod case. So consider the one-dimensional heat equation. Which is the one-dimensional heat equation? One-dimensional heat equation is UDT equals K into UXS. So this is one-dimensional heat equation. Vibration along infinite string. So analogic quantity. So it is the one-dimensional heat equation is UT equals KUXX, where It is an infinite order case. Therefore, x lies in between minus infinity and plus infinity. And what is t? T should be positive. That is the temperature. So time. T is the time. And ux0. What is ux0? Here, the initial condition is ux0 equals f of x. So this is the one-dimensional heat problem. One-dimensional heat equation is ut equals kuxx, where x lies in between minus infinity and plus infinity. Time t should be positive, and ux0 equals f of x. And so how to solve which one? Let uxt be the solution of this equation. Uxt be the solution. So let uxt be the solution of equation 1. Let u alpha t be the Fourier transform of uxt. Be the Fourier transform. Be the Fourier transform of uxt. Therefore, f of uxt, that is the Fourier transform of uxt. F of uxt is nothing but u alpha t. Okay. And what is f of x? F of ux0. And f of ux0 equals f of x. F of x is f of alpha by the definition of Fourier transform. F of alpha is 1 by root 2 pi integral minus infinity to infinity f of x e power I alpha x dx. Okay. Then, what is f of uxt? That is u alpha t. That means u alpha t with the Fourier transform of uxt means it is 1 by root 2 pi integral minus infinity to infinity uxt e power I alpha x dx. Okay. F of uxt, that is u alpha t by definition of by Fourier series transforms. By Fourier transform it is 1 by root 2 pi integral along minus infinity to infinity uxt e power I alpha x dx. And what is f ut? F of ut. F of ut equals ut alpha t with respect to t. F of uxt u alpha t. So f of ut of xt, that is ut alpha t. Ut alpha t. Why? Because t is fixed. Agreed. Now, what is f of uxx? We know that if f and f dash are integrable function, then f of x equals f of f dash of x equals minus I alpha into f of x. So here second derivative, so it is minus I alpha whole square into